Hello everyone again. I'm Gabor, and a quick intro. I am very lucky that I'm a long-time Ember fan because that means that I was lucky enough to attend it to the very first Ember Fest, and there is a photo to prove that, which is not me, it's Balint on the photo. Because there is no way I'm going to be showing you a photo from me from 12 years ago, but Balint doesn't age, so it's always a safe bet. I work with main meta to solve various problems for clients. And when I'm not working, you can find me on the fencing piece. Still not me on the photo. I wish I was. You know what? Yeah, that's me. That's me from 12 years ago. I hope you're happy now. It's babyface Gabor. But then again, I love fencing and I love competing. And this is one of the competitions I entered, and sadly, that's one of the reasons why I can't stay for tonight's conference dinner, because there's one coming up tomorrow, so I have to travel back. One of the so my main hobby other than fencing is making pizzas. And since this talk is before lunch, I thought it's appropriate to show you a very deliciously looking pizza to get you in the mood. And also this pizza thing kind of runs in the family. So this is my son and the very cute little pizza that we made together. She has a younger sister, and she would be very upset if she didn't make it to the slides. So here you are, sweetie, you making pizza. They've grown a lot since, because these photos are a couple of years old, and so have Ember. So much that Ember initially didn't even have modules at all. Because it's like it wasn't a thing to begin with. What it had is a giant Ember namespace on the global window object, and how you added your things on how you created your things in your application was by adding stuff onto your app namespace so that the global resolver would know how to resolve it. So application route ended with a route, so it was a route, and it figured out the rest from the name. And but then soon came Ember AppKit. Ember AppKit was a predecessor of Ember CLI, and it improved things quite a bit. First, only for from within the application. So within the application, we were able to export things from files and import those files elsewhere. So you were able to actually structure your application, and where you put those files began to matter, because now the resolver has changed, so you no longer put things on the app namespace. Soon after, a rename and Ember CLI followed, and with Ember CLI, for the first time, you were able to import Ember. It was not separate packages. It was just the namespace that we used before. It's just that it turned into an import. That was soon to be changed, because the ECMAScript module spec has finalized during the time, which was in 2015. And I vaguely remember that I even submitted an RFC to lay out Ember's internal modules for external consumption. This is how it initially started to look like. In the end, it didn't make the cut, especially because around that time on NPM, scope packages became a thing. So it was just a better user experience to use scope packages as opposed to have different packages for everything. So then the Ember namespace was born, and you were able to use the actual import what we are using today. And but there was a catch. It was all a lie. Underneath, it was not ECMAScript models at all. Just everything was compiled down to AMD models, because, well, it's for a simple reason. Runtimes couldn't deal with modules back then. Node didn't have native support for modules, nor did browsers. But what happened is that you got lots of these defined calls and best functions underneath. So this is from the very early Ember AppKit days. How would a model look like? But after a while, I think it began with Ember auto import, that you could actually consume the packages published to npm under the Ember source package. For example, if you look at the exports entry, you can see that the exports point towards the /this/packages folder inside the Ember source package. But of course, that there is this hasn't happened like now you pointed to the real files, because bundlers didn't so you would have had to type like import ember-source /@ember/whatever. And so that Ember has a trick for bundlers that are capable of remapping modules, which is that there is that rename modules entry. And through that rename modules entry, Ember CLI with vite or with backpack configured for the right thing, it actually just returns the module for the actual file what you requested. And so this means that you don't have to use the import Ember source /@ember what I just talked about. And this is actually a fantastic thing. So we didn't have to update our imports for years, and even though everything has changed underneath, which is great. But as I've heard, the birds are chirping that it might change in the future. I don't know exactly when, because it'll likely need some undertaking. But since Ember owns the Ember package, eventually these modules could be published under Ember, and you will be able to import Ember/service, and those files will be physically there for you to consume. So this, I might have to make some edits. Crap. Anyway, so yeah, let me just skip that part. No, maybe not. So yeah, this section originally meant to be a lot longer piece, but unfortunately I had to cut it short because this would have exceeded the entire talk. But thanks to Chris, we went very deep into how this works in Embroider and Ember and everything. And I wanted to give you the full Chris experience, but in the end I fell short. So this is all very complex, but to simplify this, let's talk about how to use and look at even to virtual models in vite. Because of, but the thing is that it's not quite vite, because rollup introduced that concept, and since vite is basically just a layer above rollup, adding fantastic developer ergonomic things like hot module reloading, dev server, etc. It's actually rollup that does virtual models. And how it does that is it actually relies on two plugin hooks. So you would have to write a plugin to create virtual models. And those two plugins are Resolve ID and Load. And in Resolve ID, you tell rollup or vite that you will handle this module. And in Load, you actually return the contents of that module. Oops. Oh. So I'm going to read it loud. This and everything. So I have a note to do, make up some funny real word like story about lying. Sorry. Want to skip this? Oh, maybe not. Okay. I can do it. So let's suppose you're who lies, like you're a politician. No, sorry, no, maybe not. It's a bit of offensive. Let's say you're a policeman or no. Okay, policeman. Perfect. It's plausible. It'll look good. So let's suppose you're a policeman and you were just playing solitaire at the police office or eating donuts. I don't know what to do. That's probably it. And all of a sudden, your superior officer comes in, and he asked like, "Hey, someone, please fetch me that kilo of cocaine from the drug raid what we seized like some time ago." And you freeze for a second, and you jump up immediately and say, "Oh, I do it." And oh, and by the way, so he just complimented your new Ferrari just this week, and it's custom Italian leather interior, and which is likely not going to be in your price range because your day job is effectively substituting traffic lights. So what do? So of course you go down to the basement, you get creative, and go back up, and you are, sir. And he's like, "This is it? The kilo of cocaine?" And you're like, "Sure. Or a kilo of 00 pizza flour." I'm not an expert. So, but the point is that he's like, it's just, all right, fine, we'll just burn it. And he walks away and properly dispose the evidence, supposedly. And you drive away to the sunset in your Ferrari, I guess. I don't know. But the point is that when okay, so for this I have actual slides. So when the resolve ID is for, hey, I want to handle this import, and load is actually return the model contents as a string. And for you as a user, you have some conventions to follow, and these conventions come to naming. So the first one is to signal the users of your package, users of the model, that it's a virtual model. You do that by preparing a virtual column to the model import path. And the second convention, that inside the resolve ID, you should return the module name with a \0 prefix to prevent other modules to treat it, to process it, because it's an invalid module name. There is one caveat, and it's stated on the vite docs, is that you should not do it if you want to have source maps working, because like this is completely removes it from reality essentially. And so it's not. So these things are not mandatory. For example, these are some package naming examples. The first one is is not a virtual model to begin with. It's just a loader. However, there is a catch. I thought it's interesting, so I just added it to the list. Is that by saying .component, you prevent vite from doing the default behavior, and that default behavior would be to return strings return a string for an SVG if you import them. And also, vite ships types with common file formats, so you would actually have the types for an SVG that it is a string. The second one is an import that points to an icon. It is very recognizable because a tilde character is invalid in module names and is definitely not a relative path or absolute path. The third one is the recommendation, and the fourth one is from embroider. This is also fine because the embroider namespace is very likely that that's not matched by other plugins, and it has virtual in the name. So people would look at it and recognize it that it's a virtual model and would not look for the actual files. Vite has excellent docs, and this is the simplest virtual model you can create. In resolve ID, if you match the virtual model ID, you return the resolve virtual model ID, meaning that you will handle that module under a different name. And inside load, you handle the resolve module ID, because simply virtual module ID won't be processed by anything, and you return the model as a string. As an example, like a practical example, I figured it's fine to create something like a made-up single file component. So this is a hypothetical single file component with the .sfc extension, and it has a function which is a default export inside the script tags, and some style under the style tag, and inside the main.js you would import the component .sfc, and if I just call the function, it should log hello from SFC, and the body would also turn to rainbow. There's no such color; it's a lie. Anyway, so this is the pseudocode, or at least the comments for this plugin. Inside resolve ID, we resolve something called virtual CSS file. This file does not exist yet, and inside the load function, we either return the code for the physical script, like from the physical file, and return styles for the virtual CSS file. So the actual code looks like, if the file ends with .sfc style.css, and then we return the ID signaling that we'll process that file, no other plugin should process it. Otherwise, we just return null and opt in for the default behavior. And the load function is that if for the actual file, for the .sfc file that physically exists on the disk, we first create another module ID called which is the same, plus we append the style.css at the end. And of course we extract the code from the script tag, and this is very important, we add another import at the end of the file, which is because that when this file is processed again by vite, it will try to resolve the additional imports which we added. Because if we didn't do that, imagine that if we created a virtual module that has imports in it, if we publish that to module imports would never resolve. So vite actually processes this file yet again. And of course generate the source map and return the code and the map. And if it ends with style.css, the module we just created and resolved in resolve ID, we extract the CSS and generate the source map all the same. And you might ask that why it's style.css and not just style. It's another trick which has vite you covered, because CSS is handled natively by vite. So which means that if you point to a CSS and vite will be able to resolve it, and you get actual contents, vite will handle the loading for you. So whenever you load the module that pointed to that imported the CSS file, vite will load that CSS whenever you import that module in your application. So this is why we add .css at the end. So vite will treat it as an actual CSS file. And sure enough, if we compile it, it will add it to the bundle, and the application will log hello from SFC, and the body is rainbow. This is a bit hypothetical, but kind of explains how it works in general. I have another use case, which is an actual solution for an actual client, and it was revolved around schema generation. The application needed to have components, but also needed components in a sense that you would want to use them in a content management system through its visual editor. But it also had to make it work with angle bracket invocation. For example, if you have a button, you would want to reuse it in other components using the angle bracket invocation, but you may also want to add it to the page using the visual editor of that content management system. So you either pass the args through classic args, and or you would fill out the form, which then later saved into the database, and you load the page, getting the data back. The type definitions for the component look like this. On the left, we see the classic args definition. So this component has a title, which is a string, description also a string, and a link, which is some data structure. And for the component, for the CMS, we had to perform a sort of database migration. So we would have to generate a component schema. We definitely don't want to type it by hand. But the important bit here is that this is effectively just a migration, like making the CMS have the correct inputs for components. And of course, it has some extra things in it. For example, it has that for the text area, it has that max length of 120 characters, which we don't have if we have types. So how we solved it is that, and by the way, when we request a page, the payload returns just the data, no type information whatsoever, which is problematic because for some fields we had to do some transforms. For example, we would have a rich text field which came back as a complex nested data structure, something that we would never want to feed into a component because we don't want to deal with such data structures at the component level. We only wanted to have strings, which is sensible. So where to get the schema from? Actually, it was. So it took us a little while to figure out, but when we made the proof of concept, everything clicked, and the solution was to extract the archetypes from the component files. We had to make some tweaks. For example, like I said, the string can't possibly cover all the use cases of string inputs because we have text area, we have rich text input, literally everything. But so for that, we had to add some additional types, which most of the case were just aliases to string, because then if you're adding a text area, you still expect, again, if you're using a text area on the CMS, you still expect a string at the component level. And we can add some additional things like max length, from which the schema could be generated and uploaded to the CMS, so that the CMS data structure is in sync with our components. And this is how we would use it at the application level. So when we render the page, we just import that component schema as a virtual model. And inside that virtual model, what happens is that we parse the component files and extract the types. We use the ESLint for that. It works flawlessly, and render the document using that virtual schema file. And we didn't have to run a different server watching files, anything. It just integrated straight into the application. So it behaved exactly the same as when we built the app and when we rendered the dev server. So we managed to solve it, I think, in a clever way. Still with me? Well, if you are thinking of lunch, or you're still with me, I have this brilliant 4-cheese pizza with truffles on it. But to get back to the talk, I have some helpful plugins to share with you that makes it easier to write virtual modules. One of the plugins this is basically the starter pack. I think this is the most common one. It covers the basic use cases. You basically just pass a module name, what you would want to use inside your application, and on the right hand side, you either return a string or an object which is serialized, or a function from which you can return the string that you would want to add to your module. And what we use for the previous example, we use vite plugin virtual modules, which has a bit more features. For example, file watching, What else? Query param parsing, customizable module naming scheme, etc. So this is actually if you have a bit more complex use case than the simple ones. And there are, of course, a few packages just to, if you want to peek into them or use it straight in your application, that are built with virtual models. The first one is not a virtual model package, but it's so cool that I'm going to sharing it with you anyway. This is just a loader. Simon, I think he's not here, but he created this model. It used to be a number-specific thing, but now it's a Karst framework package, and you can use it with pretty much any framework you wish. The second one, this is a real virtual model thing. This is a neat one. So you basically import SVGs, but you don't deliver them as separate files, but instead it concatenates the files and you ship it to your CDN as a SVG sprite. So whenever you reference SVGs, it just references parts of that sprite. So that makes the requests to essentially we'll have a fewer requests. And of course, no talk can finish without one more thing, and this is no exception. When I was researching and trying to find good examples for virtual models, I bumped into a package or set of packages, and I was curious. Like, this was so wasteful and so inefficient that I tried to challenge the state-of-the-art AI to try to come up with something similar and see who wins in terms of inefficiency. And so that I gave the prompt that suggest me a way to create JavaScript data object, burn as much coal as possible. To ChatGPT's defense, it understood that it's a metaphor, so that in a short while it came back still thinking, burning more coal. After a while, it came back with the actual solution, and the code does not matter. It just added unnecessary things to creating a data object, but it didn't even come close to what I've seen. So there is a package on npm, a set of packages which begins with the year, and if you try to use that package, you can import specific days, and it's not like these are actual files existing, and they just return new datetime, date.utc, and whichever. So of course this was begging for a vite virtual model reimplementation. I didn't do that, but to the author's defense, he created it as a showcase for a virtual model blog post, I think. Which is like, so this is you import a date beginning with dates colon, and you pass the date, and it will do exactly the same thing. It's just that it won't have like physically automatic, because like the previous package only had dates from starting from 1970 until 2038, because like the verdance in 20, I don't know, but it was hopefully it was a practical joke. But I was on a roll, burning coal, so I did what no one environmental conscious would do, should do. I texted ChatGPT back, and I said, "Thank you," just to burn a little bit more coal, which is coincidentally the last slide of my talk. So thank you so much for listening through, and hope you'll have a great conference.